All right, so note that our Unit 3 test is going to be on Monday. It's in class, 10-6. So all your homework is due by then. So just so we're all on the same page. We left off talking about the quadratic formula, and the quadratic formula is your catch-all for solving quadratic equations. So if you're not good at factoring, you're not good at completing the square, then the quadratic formula is going to be your best friend. So for the quadratic formula, it is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey, I cannot say it normal. I just automatically, if I try to say it, it's going to turn into the song. Now, what we're going to be focusing on is what's underneath the quadratic. So underneath the quadratic, this right here is called our discriminant, okay? Your discriminant is the first thing that you can evaluate from the quadratic formula, and it's going to help you determine what type of function model, well, not function, what type of solution you can have. So these are the rules for our discriminant. When your discriminant, b squared minus 4ac is greater than 0, which means that it is a positive number, that means you have two possible solutions, okay? That means that your quadratic function is crossing the x-axis twice, all right? If your discriminant is equal to 0, so b squared minus 4ac is equal to 0, that means that your vertex sits on the x-axis. So notice that my vertex is sitting on the x-axis, and therefore there's only one real solution, okay? Next, notice if you have b squared minus 4ac is less than 0, which means that underneath the square root, you have a negative number. What happens is that means that your parabola is floating. Whether it's floating above or below the x-axis, it is floating. And because it's floating, there are none, or I don't think y'all can kind of see it. I'll try to make it a little ghost. It says none. There are no real solutions. There are only imaginary solutions, which is why my none is imaginary, which we'll talk about a little bit later in the lesson. So there's no real solution. So when we say number of solutions, there's no real solution. It's written boo-boo. Okay. So there's no real solutions. All right. So let's dive in. So here it says use the quadratic formula to solve. So before we start, we're going to look at the discriminant to determine what type of solution I'm going to have. So again, your discriminant comes from the inside of x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. Okay, your discriminant is what's underneath the square root. So making sure that you understand where each variable comes from, we know that your a is going to always be with your quadratic term. So our a is the coefficient for our quadratic term. In this case, it's going to be 3. Your b is your coefficient with your linear term, which is your x to the 1. So that's going to be negative 4. And your c is your constant, so negative 1. So to determine what type of solution I'm going to have, I'm going to first find the discriminant. So finding the discriminant, I think I spelled that right. I hate spelling this word. I either put extra I's or extra M's. Who knows? Huh? I put extra something. Oh. And so when you're finding it, all you're doing is the part that says b squared minus 4ac. Okay? So this is going to lead me to the square root of negative 4 squared minus 4 times 3 times negative 1. I do not know why my 4s keep like looping. It's kind of crazy. 4. There we go. All right. So this is going to give me 16. A negative 4 times 3 is negative 12. Negative 12 times negative 1 is a positive 12. So this equals the square root of 28. Okay? Because I have a positive number as my discriminant, I know that I have two real solutions. Does that make sense? Okay, so you know that you have two real solutions ahead of you. So now we're going to go ahead and do the full quadratic. So x equals negative b, which is negative 4, plus or minus the square root. And we already found our discriminant, which is 28 all over 2 times a. Okay, so once I've plugged this in, I'm now just going to simplify. A negative times a negative makes a positive, so that gives us 4 plus or minus. The square root of 28, well, square root of 28 is not a perfect square, but the square root of 28 is made up of perfect squares, right? Is made up of a perfect square. The square root of 28 can break down to be the square root of 4 and the square root of 7. Agreed? Because it has a perfect square, I have to take that perfect square out. What is the square root of 4? 2. And square root of 7 is prime, so it's going to stay underneath there. And 2 times 3 is 6. Okay? This is a solution, but it is not your simplified solution. The reason why the solution is not simplified is because your constant and your coefficient, well, your constants have a common factor, right? All three of these numbers can be divided by what? 2. And because they have a common factor, your final answer is dividing those numbers by. All three have to have that common factor. Does that make sense? So all three have to have that common factor. So I can divide 4 by 2. I can divide 2 by 2. I can divide 6 by 2. And that's going to give me my simplified answer. So 4 divided by 2 is 2. Good morning. Oh my God. Okay, so as I was keep going, notice that when you have the plus or minus, what that means is that you have two solutions, which makes sense because when we did our square root of 28, we had a positive underneath our square root, which meant that I should end with two real solutions. Okay, so on your assignment, there is an option usually where it'll give you the option for plus or minus. If it gives you the option for plus or minus, then you can input it as so. If it does not give you the option for plus or minus, then that means you're going to separate your two solutions. Okay. You're separating them as an addition problem and as a subtraction problem because that's what the plus or minus means. Capiche? Questions, comments, concerns about how to use a discriminant? I really feel like I spelled that wrong. I didn't though. Okay, okay. And so we're gonna keep going. So we're gonna do another example. This time we're going to talk about it algebraically and graphically. So when you look here, it says a person's heart rate after x minutes is given by f of x equals 2x squared minus 24x plus 192, where the heart rate x is between 0 and 6. Determine when the heart rate was 128. 128. So symbolically simply just means that we are looking at a table. Symbolically, graphically, are using the calculator. Numerically is where you're solving it by hand. Okay. So if I'm doing this numerically, it gives me my function. So we have 2x squared minus 24x plus 192. And it says that it wants to know when does it equal 128. So when does this equal 128? Okay. Now, before you can solve any quadratic, it must be equal to 0. So the number one thing that has to be true is that it has to be equal to 0. So currently I'm not equal to 0. So I'm going to subtract 128. And what I do to one side, I'm going to do to the other. And we're left with 2x squared minus 24x. And we get plus, is that 64? equals 0. Okay. Now, what I want to talk to you about here is that notice how all of these numbers are even, which means that I can make these numbers smaller and more manageable. I can do that because I can divide every single number by 2. Do we see that? So I can divide each one of these numbers by 2 and make it a more manageable problem to solve. 2 divided by 2, and that's because if I just divide 0 by 2, is it going to change the value of this equation? No, it's not. So 2 divided by 2 is 1. So we get x squared. 24 divided by 2 is 12x. And 64 divided by 2 is 32. And 0 divided by 2 is 0. So now I went from something that seemed like a more complicated quadratic to actually a simple quadratic. We know that it's a simple quadratic because your leading coefficient is a 1. Okay. So with simple quadratics, remember, all we're asking ourselves is what multiplies to give me 32, but will add to give me 12. So what two numbers will multiply to give me 32, but add to give me negative 12? Anybody, everybody? Negative 4 and negative 8. So this would factor out to become x minus 4 times x minus 8 equals 0. And because it's just now simple factor, all I'm asking is, what would x have to be to make this equal to 0? What would x have to be to make this equal to 0? So my two solutions would be x equals 4 and x equals 8. Okay. Now, in regards to this problem, though, it gave us a domain restriction. Our domain restriction is from 0 to 6. So which one of our x values fits in our domain?